This 11th set of lecture videos is going to cover topics relating to properties of gases. The goals for this chapter are: use Charles's law to determine thermal expansion of gases, apply Boyle's law to calculate volume changes of gases, relate gas density to pressure and temperature. The first gas law we are going to take a look at is Charles's law. Charles's law relates temperature and volume of gases. It tells us that if the pressure on a gas is constant, the volume is directly proportional to its absolute or Kelvin temperature. Remember, to find the absolute temperature in Kelvin, we will take the temperature in Celsius and add 273. As a proportion, since volume and absolute temperature are directly proportional, this means that V divided by T equals V prime divided by T prime, where V is the original volume, V prime is the final volume, T is the original temperature, and T prime is the final temperature. Another way you can think of this is that V times T prime equals V prime times T. Remember, the primes indicate the final values, not the original values. If two values are directly proportional, this means that as the volume increases, the temperature also increases. Conversely, if the volume decreases, the temperature also decreases. You could also say that as the temperature increases, the volume increases, or as the temperature decreases, the volume decreases. Let's take a look at a visual example of Charles's law. If you take a bottle and put a balloon over the end and set it in a pan of water, the balloon kind of just falls over to the side, like on the left side of this picture. But if you start heating up the pan of water, the temperature change in the bottle increases, which means the temperature in the balloon increases. As the temperature increases, the volume of the balloon also increases. You might have observed this if you have ever bought a helium-filled balloons at a store on a winter day. As soon as you go outside, the balloons seem to shrink. But as soon as you get them back inside again, they go back to their original shape. This goes to show that as the temperature increases, the volume increases, and as the temperature decreases, the volume decreases, assuming the pressure is constant in all situations. Let's go through a calculation of Charles's law. A gas occupies 650 cubic centimeters at 20 degrees Celsius. At what temperature will the gas occupy 710 cubic centimeters? First, we will write down all of the data we were given. We know the original volume, V, is 650 cubic centimeters. The new volume, V prime, is 710 cubic centimeters. The original temperature, T, is 20 degrees Celsius. However, we need to use the absolute temperature, so that means we will need to convert to Kelvin. To do that, we will add 273 to the 20 degrees Celsius and end up with 293 Kelvin. We are trying to find the new temperature, T prime. The basic equation we will use is Charles's law, which says that V times T prime equals V prime times T. We can rearrange this to solve for T prime, so T prime is equal to T times V prime divided by V. Substituting, we have 293 Kelvin times 710 cubic centimeters divided by 650 cubic centimeters. This gives us a new temperature of 320 Kelvin. However, since our original temperature was in Celsius, our answer should also be in Celsius. 320 Kelvin minus 273 is 47 degrees Celsius. This concludes our discussion on Charles's law.